The task on today's example is to evaluate for given values of x, so f of -1, f of 0, and so on. And then after we get all those values, we're going to determine if any of them represent the vertical asymptote, a hole, or possibly the y-intercept. And the last of the three tasks after we evaluate and identify the characteristics is to find the matching graph. There are three graphs at the bottom that we can match up with. So first let's concern ourselves with evaluating in each case. So I'm going to set up the equation above as given, leaving space to evaluate given various values. So the first one I want to plug in -1 to figure out what f of -1 is. So I plug it in for all possible values of x, right in there. Okay? And when I evaluate, -1 plus 1 equals 0. And in the denominator, I get -1 squared is 1. -2 times -1 is plus 2, and minus 3. So I get 0 over 0. So f of -1 equals 0 over 0. The second one, again, I'm going to use the same equation, but I'm going to plug in 0 everywhere x occurs. So as I plug in 0, and now I'm going to evaluate, the numerator becomes 1, and the denominator becomes 0 minus 3, so -3. So f of 0 is -1/3. The third value, 0 plus, sorry, not 0, x would be in each of these locations. I'm going to plug in 1 everywhere, and now evaluate again. 1 plus 1 is 2. In the denominator, I get 1 squared is 1, minus 2 times 1, minus 3. That's going to give me a total of -4. So f of 1 equals -1/2. Again, now when x equals 2, set up again, plug in 2. The numerator is going to become 3. The denominator is 4 minus 3. That gives me -3. So f of 2 equals -1. And my very last one, f of 3, is what I'm looking to evaluate now. I'm going to plug everything in, put a 3, and a 3, and I evaluate up top. I get 3 plus 1 is 4. Bottom, 3 squared is 9. Minus 2 times 3 is -6. -3. 9 minus 6 minus 3 is going to give me 0. So that equals 4 over 0, which is what we call undefined. So now my task, I've got them all evaluated. My next task is to identify whether or not these values represent a vertical asymptote, a possible hole, or the y-intercept. So by definition, a vertical asymptote is when it's undefined. So any value you plug in that would be undefined gives you a vertical asymptote. So that means that my value of 3 is where my vertical asymptote is. So at the line x equals 3, that is my vertical asymptote. Looking for a hole. A hole is when you get the output of 0 over 0. So that would have been when x equals -1. So that produces a hole at when x equals -1. And the third one, the last one, is your y-intercept, and that's whatever output you get when your input or x value is 0. So this is my y-intercept. So now on my graph, to look at what constitutes the matching graph, I want to look for the y-intercept being at negative 1/3, and a vertical asymptote, that's the easiest one to identify, is at x equals 3. So when I come down here, the very first graph, I have 3 graphs to consider. And when I look at my first graph, the asymptote is in the correct place. The y-intercept is also in the correct place. And in this case, my hole is not clearly graphed. It's hard to see, but there should be an open circle where x equals, the hole is at x equals negative 1. It's not clearly shown because it's kind of overlapping. It's just too small of a graph, but there is a circle there, an open spot on x equals negative 1. So your answer is the first one. If you look at the other 2 graphs, the y-intercept does not end up in the right place. The vertical asymptote does not end up in the right place. Neither does the y-intercept. So it has to be the first graph.